So 2.6, formulas and applications of geometry. Okay, so literal equations. So I looked up the definition of literal so that you can see the connection with why these are called literal equations. And so I've highlighted these definitions. This comes from the Oxford Dictionary. And so the two definitions that are related represent the exact words of the original text, and then expressed by a letter or letters of the alphabet. So literal equations are equations where you have multiple variables. So instead of just solving for x, you might have 4, 5, 6 different variables. And so because we have multiple letters, that's where it matches with the definition of literal, expressed by a letter or letters of the alphabet. And you can also create these by directly translating sentences into English, basically like a word-for-word translation, which is why I also highlighted the representing the exact words of the original text. It's like you're taking some relationship and translate it into mathematics, and you use many variables. So an example I have here is the area of a triangle is half of the base multiplied by height. So translating that into a literal equation would be A equals 1/2 B times H. So B is the base, H is the height, A is the area. So that's a literal equation because we have 3 variables there instead of just 1 variable. So that's what literal equations are, and you've seen them before. Like I'm sure you've seen equations for area, like length times width. So you've used these, you just probably didn't know what the name of them was. So these connect to formulas because most formulas that we have are literal equations. And so what makes something a formula is that it has a specific use or application. So not every equation is a formula, but every formula is an equation. So some examples of common formulas are formulas for area, perimeter, distance, temperature conversions. There's a formula for that. Formula for circumference of a circle. The simple interest formula. We have the ideal gas law. The force formula, like F equals MA, Ohm's law, V equals IR. So these all have specific applications. They're not just like 2x equals 10. So 2x equals 10 is not a formula because it doesn't connect to an application. It's still an equation, just not a formula. So that's the difference. And most formulas have multiple variables, and you end up plugging in numbers into more than one variable. So you might be replacing, like if you have the area formula here, you'd be replacing B and replacing H with the values you know, and then you can use that to find the area. So the hard part is solving these equations for a specific variable. So you've gone through solving an equation with numbers and solving for x. Now you're going to be solving something for a variable. So when we do this, we're following the same steps as if you're just solving for x. So you still do the distributive property to simplify both sides. Then once you've simplified both sides, you add or subtract things until your variable is isolated, or it's everything with your variable is by itself on one side. And then you divide or multiply so that whatever is combined with the variable or multiplied by the variable you can get rid of. So it's the same steps that you've been doing. It's just now we're doing it with letters, which are just representing numbers. So it's a little more abstract. So I'm going to show this in 2 ways, with numbers and without numbers. And I have, in the one with numbers, there are 2 variables, but it's usually a lot easier to follow than with what's on the right side. So I'm going to show you how it kind of works side by side. So I'm going to start with our 2x plus 3y equals 10. So it says that we want to solve this for y. So we want to get the y by itself. We don't have any parentheses here, so we need to do any distributing. So the first step is your addition or subtraction, where you're subtracting unwanted things or adding unwanted things to you're moving them to the other side. So we have a 2x that's added on here. We don't want 2x on the same side as the y because we want to get the y by itself. So we are going to subtract 2x from both sides. So I'm going to subtract 2x. And now I'm actually not going to put it underneath the 10 because the 10 and the 2x are not like terms. So I'm going to just, you can pretend that there is a 0x up there if it makes it easier for you. Okay, so I'm subtracting the 2x from both sides so that I can get what has the y by itself. I can get that by itself, basically. So the 2x minus 2x is 0, so that is gone. And now I have a 3y, and then I have a 10, and then 0 minus 2, that gives us a minus 2x. So we're still trying to get the y by itself. And so now that you've got a single term on the left that contains our variable, we're going to divide everything by 3, which is in front of the y. It's the same thing as if we were like solving for x, and if you have 2x, you're dividing 2. So we're going to divide everything by 3. And usually when we do this, we just write it as a single fraction. But if you wanted to, you can also divide each individual item by 3 and write it that way as well. That's the same thing. So on the left, the 3's cancel, and we have y, and then we can get 10 over 3, and you can write this as 2/3 x. And so now what we've done is we've solved this equation for y. So solving for a variable means you have that variable by itself. We follow the same sort of set if we were solving with just regular numbers. It's just that we have extra variables in there, and that's completely fine. We still did what we were told to do, which was solve for y. So we can compare this if we have something without any numbers. We have ax plus by equals c. So we are still solving for y. So we're still trying to get y by itself. So we need to move the ax. And if there's no negative sign, we assume it's a positive number, so we're going to subtract. So you can see that it's basically the same thing as what we had on the left, but we had a number there. Now c is not a like term as ax because they're not matching with their letters. Their variables are not the same, so those are not like terms. And it's almost easier to see that when you're only using variables. So the ax minus ax, those cancel because one's positive, one's negative, so they go to 0. Then we have by equals c minus ax. So you can see that it's very similar to the form we had on the left where we had numbers present. Now we're still solving for y, which means we want to get rid of that b. So if it's attached and there's no plus or minus in between those letters, it's assumed to be multiplication. So that means we're going to divide, just like we divided by 3 on the left side. So we're going to divide by b. And generally, if all we have are variables, we will just put it under a single fraction there. So These cancel, because b over b is 1, just like x over x, those cancel, and we're left with y. And then usually if we don't have any numbers at all, we will just write it as a single fraction in this form. But you can see the similarity on the steps. Even if the left side had numbers, the right side didn't. The steps are the same. Are there any questions? Okay. So here's another example. We have a literal equation, and we have P equals A plus B plus C, and we want to solve for the letter B. So I'm going to go through a series of examples, each showing the different types of solving that you do when you have literal equations with lots of variables. So this is the most simple version, is when you just have a whole bunch of things added together. So we want to solve for B. So I'm going to just rewrite here and then highlight what I'm solving for. So I know I don't want to move that. So on the same side as B, we have A and we have C. So we need to get rid of both of those. So I'm going to start with just the A first. So we assume it's positive, so we're going to subtract A. Now A is not the same as P, so I'm going to move it to the left. And if it helps, actually I think that, I don't know, that might not help. But I'm going to move it to the left. And so the way that we write this is I'm going to drop down. I have a negative A, and then we're going to put a plus sign between that and the P, because that's a positive P. And now on the right, I got rid of the A, because A minus A, those cancel. So we have B plus C. So we want to solve for B. So now we want to subtract C, because that's on the same side. So I'm going to subtract C from both sides. And the C is not the same variable as the A or the P. So again, I'm going to put that kind of off to the side. So I have a minus C, and then I have a minus A that drops down, and then I have a plus P equals B. Now often if we have something that's positive and then several things that are negative, we will just rearrange this and write it as P minus A minus C equals B. It's the same thing, it just looks a little nicer by having the positive thing first and then putting the negatives after it. So we got B by itself, so that means we have solved for B. Are there any questions? Okay. So now we're going to move on. This one looks kind of complicated. We want to solve P1V1 equals P2V2 for V1. So those numbers underneath, those are subscripts. And subscripts are labels. So it's just labeling these. It's just saying we have two variables with P, two variables with V. So we're just keeping them different by putting subscripts, the first one and the second one. So we are solving for V1. So I'm going to start by rewriting this. So I have P1 V1, P2, V2. So we want V1 by itself. So it's already, it doesn't have anything added or subtracted to that side, so we don't have to do any addition or subtraction. What we have is a P1 in front of there, and we want to get rid of that. So that P1, V1, because there's no plus or minus in between those, that's assumed to be multiplication. So we want to divide both sides by P1 in order to get rid of it. Because anything divided by itself is equal to 1. Like 2 divided by 2 is 1, so P1 divided by P1 is 1. They just cancel. So this leaves us with V1, and then we just write exactly what we have, P2, V2 over P1. And now we've solved for V1. I actually think solving literal equations is almost easier than solving a regular equation because you don't have to worry with any numbers, you don't have to do any arithmetic, you don't have to simplify, you're just literally writing what you do. Are there any questions on this example? Okay. Next one, so here we're getting a little more complicated because now we have parentheses. So we solve equal, or P equals 2 times L plus W for L. So we want to solve for L. Now, if you are solving for a variable and it's inside parentheses, in order to get out of the parentheses, you have to distribute. So that's the only way that we can get it outside of the parentheses so we can start moving things around. So our first step here is to distribute. And so you're just distributing the 2 through the parentheses. So that gives us 2L plus 2W. So if it helps you, you can highlight what you're solving for. So we're trying to get the L. And I have something added on, so I need to subtract it so that it's not on that side. So I'm going to be subtracting 2W. Now instead of writing minus 2W plus P, I'm going to do the P minus 2W just because that looks a little nicer. And then I have 2L. So again, we are solving for L. So in order to get the L by itself, we have a 2 in front, so we need to divide everything by 2. So because I do have some numbers involved, I'm going to divide each of these separately, especially because I can cancel out the 2 with the W. The 2W over 2, those 2's will cancel. So this leaves me P over 2 minus W, because the 2's divide and they become 1, and then equals L. And so now I've solved that for L. Now this particular example, this formula is actually the formula for perimeter of a rectangle. So there's a length and a width of a rectangle, and there's 2 of each. So this would give you the equation for a perimeter. So it's useful to solve for L if, for example, let's say you were in some sort of field or you had some sort of problem where you knew the perimeter, or you knew what the perimeter was. Maybe you're making fencing and you know the perimeter, the total amount of fencing that you have, and you know that one side, the width has to be a certain length. With this, solving this for L, you can plug in your perimeter, you can plug in your width, and then that gives you the length in order to use all of your fencing. So let's say you were just, you were somebody that builds fence, and you just happen to know how much fence you need to use, and you always have a width, and you need to figure out how long to make the fence. you would use this formula over and over again, and so it'd be easier to solve the original formula for L, so that way all you have to do is plug in numbers versus plugging in numbers in the beginning and then going through the solving. Because it's usually, if it's a formula you're going to reuse over and over again, and you're always looking for the same thing, like you're always trying to find the length, it's just quicker to solve the literal formula first and then plug in the numbers. Because that way all you need to do is plug in numbers and you can make like an Excel spreadsheet for that. Versus trying to put it in the beginning and then reworking the math over and over and over again. So that's one of the reasons that we have a skill like this, is because there's problems like this that apply in the real world. And it's, it'd just be a lot easier to have this formula. So a kind of side example here is the formula for temperature, which I always forget the exact formula. So I'm just going to quickly, okay, so the Celsius, let's see, so the Fahrenheit is 9/5 times the temperature in Celsius plus 32. So let's say you always have Fahrenheit temperature and you're trying to convert it to Celsius. This would be annoying to plug in a number for F and then to have to do the math over and over and over again. So it's actually easier if you solve it for Celsius first, and then all you need to do is plug in the number and work the math, rather than having to solve this over and over again. So this is actually, solving this, it gives you the formula in the other direction, like if you want to find Celsius. So if we're looking for Celsius, the first thing we would do would be to subtract 32 from both sides. So that gives us the Fahrenheit temperature minus 32 equals 9/5 C. Now I'm actually going to change colors here. So the 9/5, we want C by itself. If you divide by a fraction, that's the same as multiplying by the reciprocal. So you'd be multiplying both sides by 5/9. So doing this gives us the formula for Celsius, which is 5/9, and then in parentheses F minus 32. So if you knew that you were going to be doing a lot of conversions to Celsius, it'd be a lot easier to plug it, to use this form of the equation versus the top form, because then all you need to do is plug in your Fahrenheit, subtract, multiply, versus solving. Are there any questions? Yes, Omar. P minus 2W divided, yes, that is, yes. So the alternate form, P minus 2W over 2 equals L. This is also mathematically correct. So that's an excellent question. Those are equivalent. It just depends on how you prefer to simplify it, basically. Any other questions? Okay. Now here's when we have a fraction. So we have Q equals A minus B over 2, and we want to solve for A. So I'm going to rewrite this. Q equals A minus B over 2. So if A is on the top of the fraction, what we're looking for is on the top of the fraction, what we need to do is to multiply both sides by the denominator first, so that we can kind of get the top of the fraction by itself. So we're going to multiply both sides by 2, so we can get the A minus B by itself. So that gives us 2Q, and then the 2 and the denominator cancel, so we're left with just A minus B. So we're looking for A, and we have this B that's on the same side. So since that's a minus B, we're going to be adding b to both sides. So generally the way we will write it is we'll just start with our 2q and then we'll put the plus b after that versus b plus 2q. It really doesn't matter. And then that is equal to a. So we got our a by itself. So that's another technique where sometimes you have to multiply both sides first to get rid of fractions in order to solve for what you want. So moving on to geometry applications. So I didn't want to go too much into detail on this because it's mostly just using formulas and just basically knowing which formula to use and plug it in numbers. So I did think it would be very helpful for you guys to know some common geometry formulas. So area of a rectangle is A equals L times W, where L is the length, W is the width. So we try to use variables that make sense for what you're looking for. Perimeter is P equals 2L plus 2W, or we solve the alternate L plus W with the 2 in front. Those are equivalent. Those are the same thing. If you have any problems involving complementary angles, those are angles that add up to 90 degrees. So you would usually have something like A plus B equals 90. And so maybe you know one of the angles and then you're solving for the other one. Supplementary angles add up to 180. So that would be very similar, but they would be equal to 180. Vertical angles are equal to each other. So a vertical angle is, let's say we have two lines and they cross. This angle and this angle. Red shows up really badly. The yellow probably is a little better. There we go. These are vertical angles. So they basically are kind of opposite sides of the x. So these are vertical angles, which means that the other angles I didn't color are also vertical angles. So these angles are also vertical angles. So they're just kind of diagonal of each other if you want to think about it that way. And then lastly, the angles of a triangle add up to 180. So a triangle has 3 sides, so it has 3 angles. So all 3 of those add up to 180. So if you have anything involving angles, those are the key things. I already gave you the area of a triangle formula on the second slide. So those are pretty much the most important kind of things that you need to know if you're doing things with geometry. Those are the most common things that you use with geometry. So that's just a good reference. You can always Google if you're trying to look for a formula as well. So I did want to end with one word problem so that you can see how you can use these formulas to then solve. So whenever you're doing word problems that involve geometry or any kind of shapes, always draw a picture and label. So it says in a small rectangular wallet photo. So I'm going to draw my rectangular wallet photo. And it says the width is 7 centimeters less than the length. So first I'm going to label the width, and then I use a cursive L. I probably could use a capital L for length, just so it doesn't look like a 1. So I've labeled those sides. And now we're going to translate the word, or the sentence, or the phrase, I should say. Width is 7 centimeters less than the length. So I'm going to rewrite that just so you can see the translating here. Width is 7 centimeters less than the length. So here's some key things about translating. Wherever the word is located, that is your equal sign. So I have the word is, so that's my equal sign. So I'm going to just put a little equal there. And I can label my variables. I got width equals, and then I have my length. So I'm going to just put that up there. And then I've got a 7. Now the tricky thing is when you have equations and you have something that's less than, that tells you that you're flip-flopping the order. We're subtracting. And so the way I like to think about this is I see the word than, and I make the word than a plus symbol. So I have plus L. And then the word less is going to tell me that I have a negative. So I'm going to put a -7. So that's how I translate something like this. So I have than becoming a plus, and then the less tells me I'm going to use a -7. So that translates that. So I have W equals -7 plus L. So I can label this. My W is actually -7 plus L. So I'm going to just relabel my picture with that. So now we have if the perimeter of the photo is 34 centimeters. So that is telling us the perimeter is P, and that equals 34 centimeters. We want to find the length and the width. So we need the equation for perimeter of a rectangle. And that equation, if I use that one that we saw before, I'll just say length plus 2 times length plus width. So I know I have 34 as one of my numbers here because the perimeter is 34. I have 2 times L plus, and then instead of W here, I'm going to write what W is equal to, the -7 plus L, because that is the width. We said that that is equal to that. So, oops, I'm going to highlight that so you can see that I've replaced the W, and then that's going to be -7 plus L. So I replaced W with what we said it was equal to, that relationship. So now we have one variable. So now we need to solve for L, and we need to follow the order of operations to simplify on the right side. And so that involves adding like terms inside the parentheses first. So we have an L and an L, so we can add those together. So I have 34 equals 2. L plus L is 2L, and then I have that -7. So now I'm going to distribute 2 through the parentheses so that I can get that L outside of those parentheses so I can solve for it. So I have 34. 2 times 2L will give me 4L. 2 times -7 is a -14. So I have 34 equals 4L minus 14. So next step is to add the 14 to both sides. So 34 plus 14 is 48 equals 4L. Now, I need to get rid of the 4 because I'm solving for L, so I'm going to divide both sides by 4. And 48 divided by 4, I believe, is 12. I wanted that in black. I want to get my colors confused here. So when you're solving a word problem, what happens is a lot of people get to that end and they're like, I'm done. But you have to go back to the beginning to tell you, because it's telling you what you're finding. It says to find the length and the width. All we did was find the length, so we still have to find the width. But we have this formula that we found, that W is equal to -7 plus L. And now we know what L is, because L is 12. So W equals -7 plus 12. So then 12 minus 7 is 5. So W equals 5. Now, when we have a word problem, we want to write our answers in a sentence using the correct units and everything so that it makes sense and you're not just saying the answers are 5 and 12. So we would say the length of the photo, so that it's in context. It should go back to, you know, what the original problem was. The length of the photo is, and we have to make sure we have units. So we gave us 34 centimeters, 7 centimeters. So this is going to be in centimeters. So it's 12 centimeters. And the width is 5 centimeters. So we fully answered the question. It said to find the length and the width, and we've written it in a sentence in context so that it makes sense in terms of the original problem and what you were looking for. We're including units, and so we've got a very complete answer here. Do you guys have any questions? Okay. So that was my last slide, my last example. Do you guys have any questions on anything that we've covered this week? Because, you know, I can give you guys 15 more minutes if you want, if you have other questions and you have some things you want answered.
Do you have any examples of simplifying decimals and fractions and all that in the equation like we did on some of the exercises, 2.3,
Sure.
I think, or 2.2?
Yeah, let me pull something up.
The one where you're converting the decimals into, you know, like whole numbers.
Yeah, sure. I'm going to make some up. They're probably going to be really gross. But I can definitely do that. Let me get my screen shared again. Okay, so I'll start with one of decimals. I'm just totally making this up, so this could be really nasty. I can almost guarantee this is going to not come out to a nice number, but at least it will get the point across. So if you have a problem with decimals, so there are two options, is just to work with the decimals and just use your calculator, or you can try to get rid of the decimals and the fractions. So if there's anything with parentheses, I recommend distributing through parentheses first before you try to clear decimals and fractions. So the first thing I would do is to multiply this 2 through the parentheses first. So 0.05x. So that would give me a 2x, and then 2 times 0.25 is 0.5. So that's going to be minus 0.5 equals 10.004. Oops. Now, to clear decimals, you want to count how many numbers you have after the decimal point. So I've got 2 numbers after the decimal there, 1 here, and 3 here. So you want to take the largest number. So if I have 3 is the largest number of decimal places. So that's what I'm going to work with. And you multiply both sides by 1 with that number of decimal places, but as a 0. So I'd be multiplying by 1 with 3 zeros, or 1,000. So I'm going to be multiplying everything by 1,000 because I want to get rid of 3 decimal places So I need 3 zeros. So I still use my calculator just to make sure I don't mess up with this multiplication. So I'm going to multiply by the 0.05x, 1,000 times that. So that comes out to 50. So I have 50x. Then I have 1,000 times 2x. So that's going to be 2,000x. And then 1,000 times a negative 0.5, that comes out to negative 500. And then I have 10.004 times 1,000, and so 10,004. So now I've gotten rid of all the decimals, and now I can solve like usual. So on the left, I have like terms, 50x plus 2,000x. So I can add those. I get 2,050x minus 500 equals 10,004. Then I will add 500 because I want to have the x by itself. So that leaves me with 2050x equals 10,504. Now we want to get rid of the 2050, so we're going to divide both sides by that. Generally, if you have a problem that starts with decimals, you also end with decimals. So you would do that actual as a division rather than simplifying the fraction. And this came out really nasty, as I knew it would because I made it up. But I get a whole bunch of numbers and it goes on, and it's just going to keep going on forever. So I got a lot of decimal numbers here. So if you wanted, you could leave it as a fraction. So if we wanted to write it as a fraction, we would have 10,504 over 2050. We would need to reduce that. So I know I can divide those both by 2 because they're even numbers. So I'm going to try to reduce this fraction by dividing by 2. So I divide both the top and the bottom by 2. Now 52 is even, but 1025 is not. I don't think that reduces any further. I don't think they have anything else in common. Yeah, my calculator will not do anything else with that. So that's as far as that reduces. The other option is if you have a decimal that goes on forever, you go back to the beginning and see how many decimal places did you have. And so some, depending on the school of thought, some take the lowest number of decimal places and round to that. Some take the highest number of decimal places and round to that. What I generally do is I take the highest number. So since the highest is 3 decimal places, I would round to 3 decimal places. So if I'm rounding to 3 decimal places, then I would have 0.123. But because the 4th decimal is 5 or larger, I round up. So this would be 5.124. So that's how you would work with something that has decimals. If you wanted to clear decimals, so you'd first want to distribute, then multiply by a power of 10 so that all the decimals disappear, and then solve from there. Do you have any questions on that and solving that with, decimals? Okay, so then let's do one with fractions. And again, I'm going to just make this up. So this is probably, again, going to come out nasty. With something with fractions, just like I did with the decimal, I want to distribute first before I try clearing fractions. And when you're multiplying with fractions, when you have a fraction times a fraction, you're multiplying straight across. So the tops multiply, the bottoms multiply. If you have a whole number, you would turn that whole number as, into a fraction, so that way when you multiply, like let's say I was multiplying 2/3 by 10, I don't have to, but I would do 2/3 times 10 over 1, and then I would multiply straight across. So I first distribute 2/3 times x, so that's going to be 2/3 x, and then 2/3 times 1/2. I'm going to have a minus there, so we're going to have 2 times 1, which is 2, 3 times 2, which is 6, then plus 4 over 5 equals 10. So if you want, you can reduce any fractions that come up from this so that you can multiply by a smaller value if you want. So 2 over 6, I can divide those both by 2. That comes to 1/3. So I'm going to just do that. So I have 2/3 x minus 1/3 plus 4/5 equals 10. So now to clear fractions, you want to find the common denominator. So we've got a denominator 3 and a denominator of 5. So 3 times 5 is 15. So you can multiply both sides by 15. And you don't have to do the smallest one if you want. You can do the biggest one. It will all figure itself out. Whoops. How do I undo? Undo. There we go. Okay. So I'm going to multiply everything by 15. And because we have fractions, you're going to write that by like 15 over 1. And then I can just do 15 on the right. So I'm going to multiply 15 by 2/3. So that's going to be 15 times 2, which is 30. So it's going to be 30 over 3x. And then 15 times 1/3 ends up with 15 over 3. Then we have 15 times 4/5. So 15 times 4 is 60, so that's going to be 60 over 5. And then 10 times 50, or 15, is 150. Now, each of these fractions, because I multiplied by the common denominator, these are all going to come out to whole numbers, so you just do the division. So 30 divided by 3 is 10. 15 divided by 3 is 5. 60 divided by 5 is 12. And so that we end up with 10x minus 5 plus 12 equals 150. So now I'm going to add like terms on the left side. So minus 5 plus 12, that's going to give me 7. So I have 10x plus 7 equals 150. So I'm going to subtract 7 from both sides. It gives me 10x, oops, that black, 10x equals 143. Now I'm going to divide both sides by 10. And whenever we have a fraction that started with, or an equation that started with fractions, you keep the fraction. So you don't make it a decimal. So you would keep it as a fraction and then try to reduce it if possible. I don't think 143 has anything in common with 10, because 10 can only be divided by 2 and 5, and 2 and 5 I know don't go into 143 because it's not even, which would mean it would be divisible by 2. And it doesn't end in a 5 or a 0, so that would mean it's divisible by 5. So that doesn't reduce. So that would be your final answer. Is you would write it as 143 over 10. You don't make it a mixed number or anything. We just leave it exactly as is. Does that help? Perfect. All right, so that brings us to pretty much almost 6 o'clock, so that brings us to an hour. I'll make sure that when I send out the video, I will also attach this file as well, so that you have examples of both of those. All right, so thank you guys. Thank you for bearing with you with the technical difficulties and everything. Glad that we got all that figured out. And I'll let you guys know when the next live session is going to be. And I hope you guys have a great night. And I will talk to you guys later. And I'm glad that you enjoyed this, and hopefully you come to the next ones if you can. All right, so bye.